Hello everybody, welcome to the channel Talha and Rohan's Learning Studio. Today I just wanted to solve some past paper physics question and I decided to take you guys along with me on the journey. So essentially the past paper questions that we're going to be solving, they'll save my exams. So they are physics and the topic we're going to be covering is the effective forces, paper 2. So yeah, without wasting much time, let's just get straight into the past paper. So first question. A satellite orbits the Earth above the atmosphere at a constant speed. The diagram shows the satellite at one point in its circular orbit around the Earth. Which labeled arrow shows the direction of the resultant force on the satellite at the position shown? Okay, so essentially, in this question, you got a satellite, it's orbiting the Earth, alright, and they've shown the satellite at one point across its journey, and they're asking us to calculate the resultant force that acts on the satellite. So the first thing we need to recognize is that this question is dealing with circular motion, right? And when you're talking about circular motion, I need you to open your minds up to terms such as centripetal forces and centrifugal forces. All these things should be coming up to your mind as soon as you hear this word. So let's start actually solving the question. So we're given the options A, B, C, and D. First thing we should be able to recognize is that D is the centripetal force that acts on the satellite, and A and C are the centrifugal forces that act on the satellite. So naturally, what we can do is we can remove option D, as it indicates that the satellite is moving out of its orbit, which is not what the question says. Essentially, this option contradicts what the question has to say. So we're left with option A, C, and D. We also have studied that the centripetal forces are greater than the centrifugal forces acting on an object that is traveling in a circular path. So essentially, in this question, we know that A and C are the centrifugal forces and D is the centripetal force. So because the centripetal force is greater than the centrifugal force, the resultant force therefore must also act in the direction of the centripetal force. Therefore, we have to choose option D. Moving on to the next question. An object is acted upon by a 3 newtons force and by a 4 newtons force. Each diagram shows the two forces. Which diagram shows the resultant acts of these two forces? So before we look into the options, I want you to consider something. Consider you have a small ball and you apply a force of 4 newtons to the ball upwards, and at the same time you apply a force of 3 newtons to the ball to the right. Essentially, where do you think the ball is going to end up traveling? We can use the parallelogram method to help us figure this out. So essentially, draw a parallelogram and then we draw a diagonal line across it, and this diagonal line helps us to indicate the direction of the resultant force. So when you go back to the options, the only one that actually indicates this is option C. You can eliminate all the other options and consider option C. Okay, we'll be moving on to our next question. The engine of a car produces a driving force of 5,000 newtons on the car. Resisting forces R can also act on the car. The car has a mass of 800 grams and an acceleration of 1.0 meters per second squared. What is the value of R? So we know that the engine, it produces a driving force of 5,000 newtons forwards, but resistive forces can also act on the car. Essentially, over here, we're going to apply the formula for resultant force. So F is equal to ma. M is the mass and a is the acceleration. So F is equal to 800 multiplied by 1, which is equals to 800 newtons, right? So this is the actual resultant force that acts on the car, but not the actual resultant force that acts on the car, because we know that there is a driving force of 5,000 newtons produced by the engine, but we also have a force of 800 newtons over here. So essentially what we're going to do is we're going to subtract 800 newtons from the 5,000 newtons to get our answer of 4,200 newtons. To rephrase it in a much better way, the engine produces a 5,000 newtons of force. Only 800 newtons of force is available for forward motion, so 4,200 newtons of force from the engine is lost. The 4,200 newtons can be represented as an opposing force R. So moving on to our next question. An object moves in a circle at constant speed. Circular motion again, which statement about the force on the object is correct? So let's consider all of the options. A force away from the center of the circle keeps the object moving from the circle. A force in the direction of the motion of the object keeps it moving in the circle. A force towards the center of the circle keeps the object moving in the circle. Okay, so essentially, let's draw the center, and let's draw an orbit that the object takes, and the path using to travel around that center, essentially, or that center which has a gravitational pull. So you see this object, it's traveling, let's say, in this direction. The question is essentially asking us all three of these options, which force keeps the object in its orbit or in its path? A force away from the center of the circle, so that would essentially mean in this direction. That would not be the case, as this is the force that, if it were to act on the object, would cause the object to move out of its orbit. So we can remove option A. Option B, a force in the direction of the motion of the circle. A force in the direction of the motion of the circle, as you can see over here, would be the centrifugal force, right? And we have studied in circular motion that it's not the centrifugal force that keeps the circular object in its path or orbit, but it's the centripetal force. And the only option which describes the centripetal force is option C. So we would choose option C. So essentially, to rephrase my explanation, remember that any motion in a curved path represents accelerated motion, that is, the direction is always changing, and requires a force, which is the centripetal force, and the centripetal force is directed towards the center of curvature of the path. Answers A and D do not represent anything we encounter in this scenario and can be disregarded. Option B represents the instantaneous velocity vector associated with the centripetal force. Question number 5. Okay. A parachutist is falling down at terminal velocity without her parachute open. So we need to recognize the fact that the term terminal velocity over here means constants. She now opens her parachute. What is the direction of her motion, and what is the direction of her acceleration immediately after she opens her parachute? So that, my friends, would be option B, and the explanation is the skydiver, before opening her parachute, was at terminal velocity, which is what the question indicates over here, meaning that the forces which are acting on the skydiver or parachutist, whatever we're going to call them, are balanced, so there's no resultant force. Therefore, there's no acceleration, and the object is traveling at constant speed. Opening the parachute causes a rapid change in air resistance. Air resistance is a force. So, before the parachutist opens her parachute, the forces are balanced. There is no net/resultant force, so the skydiver or parachutist falls at terminal/constant velocity. But as soon as she opens her parachute, air resistance, which is a force, suddenly increases. So now the forces are not balanced, and there's a rapid increase in upward acceleration. And the only option which describes what I've said is option B. Another thing you have to note is that after the parachutist opens her parachute, obviously she will continue to travel downwards. Let's move on to the next question. The diagram shows a satellite that is moving at a uniform rate in a circular orbit around the Earth, or again circular motion. Which statement describes the motion of this satellite? It is accelerating because its speed is changing. It is accelerating because its velocity is changing. It is accelerating, but it is not accelerating, but its speed is changing. It is not accelerating, but its velocity is changing. Okay, so you need to remember the fact that when you study circular motion, this is, for example, the Earth, and this is the satellite. I know it's a very bad drawing. When the satellite is orbiting around the Earth, throughout the entire orbit, the speed of the satellite or the magnitude of the velocity does not change, meaning that throughout its orbit, the satellite continues to travel at constant speed, or you could call it constant speed. But however, what is changing throughout the path of the satellite around its orbit is the direction. And remember, velocity is defined as speed with a direction. You can automatically remove option A because it states that the speed is changing. You can remove option C because we know it is accelerating, and the same goes for option D. We choose option B because while the object is traveling with constant speed, its direction is changing. And if you go back to the definition of velocity, velocity is speed in a particular direction. So even if the speed remains constant, but the direction changes, we say that the velocity changes. And acceleration is defined as the rate of change of velocity. And we can only say acceleration changes, acceleration increases or decreases if the velocity increases or decreases. Therefore, option B is correct. So let's move downwards. Okay. Question number 7. What statement about an object moving in a straight line through air, remember the words through air, is correct? When it accelerates, the resultant force acting on it is zero. When the object is accelerating throughout air, obviously the forces are not balanced, so there has to be a resultant force acting on it, so it has to be not equal to zero. So you can remove that. When it moves at a steady speed, the air resistance acting on it is zero. See, if the air resistance acting on it is zero, technically the object would then be accelerating, which is known as the acceleration of freefall. It would be constantly accelerating. And you could also say that because the question says the object is traveling throughout air, the air resistance that acts on the object can't be zero, so you can automatically remove option B. And next up you have option C, which is when it moves at a steady speed, the resultant force acting on it is zero. This is the statement that I would consider to be correct, and the reason for this is Answer C is correct because steady speed implies constant velocity, and according to Newton's first law, will be maintained if a net force of 0 is acting on the object. So essentially, that's my reasoning for choosing option C. Next up, which statement about the two forces x and y, which diagram, shows the two forces x and y with their resultant force? Okay, you look through each of the diagrams, and again, this is similar to one of the questions we encountered above. The correct option would be C, because when you use another way to identify is by using the tip to tail method, which is when you align the vectors tip to tail and construct the resultant force by joining the free ends. The parallelogram method, or you also have the parallelogram method where you place the vectors tail to tail and construct a parallelogram and measure the diagonal which represents the resulting force. So essentially, we're using the parallelogram method over here. So like when you essentially extend these two forces and draw a diagonal line across them, this is the one that represents the parallelogram method and therefore is correct. Okay, moving on to the next option. For objects are acted on by only two forces as shown. Which object is in equilibrium? So you could see that because of the difference in forces, you could automatically remove option A and option C. Do not be deceived into thinking that the answer is option D, because you have to take into account the direction in which these forces are acting. You could see that the 4 Newton's force is acting in the clockwise direction, and the 4 Newton's force that's acting downwards is also acting in the clockwise direction. Therefore, they both are acting in the same direction. And if two forces act in the same direction, you add the two forces together to produce the resultant force. So you could remove option D from this, and the only one you're left with is option B. So that represents the state of equilibrium. Yeah. So moving further, the diagram shows 4 identical objects. Each object is acted on by only the 3 forces shown. When object accelerates to which object accelerates to the right with the smallest acceleration? Okay, so by using the word smallest, even though I've not read the question yet, what I could determine is that maybe there are two objects in two pictures, or two objects in this diagram, both of which move towards the right, but we need to find the one which has the smallest acceleration. Okay, so you could obviously remove option A because it represents, when you add these two forces together, it's a 50 Newton force, and when you calculate the resultant force, it would be 40 Newtons towards the left, and we're trying to see which object accelerates towards the right. Now, when you look at option B, these two forces act together to produce a force of 30 newtons. And okay, so you've got two forces which have which are equal in magnitude, but they're acting in opposite direction. So there would be no resultant force on the object, and it would be stationary. So essentially, now you have to look at option C and D. In option C, when you add these two forces, you get an answer of 40 newtons, and when you subtract that from 20 newtons, you get a resultant force of 20 newtons towards the right. Now, option D, when you add all of these forces, 20 plus 10 is 30, 30 plus 30 is 60, you get an answer of 60 newtons towards the right. Now, as I said before, even reading the question, I determined that there would be two objects which have a resultant force which is leading them towards the right. But the question asks us to find which object accelerates to the right with the smallest or the smaller acceleration, which would be option C. Okay, let's move on to question number 11. A car traveled along a horizontal road at a constant speed. 3 horizontal forces act on the car. The diagram shows 2 of these three forces? What is the size and direction of the third horizontal force acting on the car? Okay, so essentially we know that this car, it is traveling at constant speed, right? So when it's traveling at constant speed, we can say that the car has no acceleration. Or another way to describe it as if it's traveling at constant speed, all the forces that act on the car and are balanced, because according to Newton's first law, an object that is traveling at constant speed will continue to travel at constant speed unless acted on by a resultant force. Since all the forces are balanced, there is no net force acting on the car. So we know that there's three horizontal forces acting on the car, and our diagram shows two of these three forces. Now, there's a force that acts forwards on the car, and that represents the force from the engine, and there's a force that acts backwards on the car, and that represents the air resistance. But there is still a resultant force of 300 newtons that acts forwards. A force of 1200 newtons that acts forward on the car. But we're also told that there is a third horizontal force that acts on the car, but it's not shown in this question. So what could that be? We know that the forces have to be balanced in order for the car to be traveling in a constant velocity. In order for the forces to be balanced, there has to be another 1200 newtons force acting on the car in the backwards direction. Therefore, you could say that the only correct option over here is option A. Okay, so let's move on to the next question. Which list contains only properties of an object that can be changed by a force? So you need to go back to when you learned about what changes can forces bring or cause. There were about three that we learned, and they were change in speed, change in direction, and a change in shape. And the only option that shows all three is option C. So I'm just gonna go ahead and get that. Okay. So next up, you got question number 13. The diagram shows only three forces acting on the object. What is the resultant force? So this is a relatively easy question. You add these two forces, you get a total force of 500 newtons acting towards the right, and you've got a force of 5.0 newtons acting towards the left. So you've got two forces of equal magnitude, but they're acting in the opposite direction, and we've studied that this means that there should be a net force and a resultant force that is equal to 0. So I'm just going to take option A. Okay, just going to move on to the next question. In which situation is no resultant force needed? A car changing direction at a steady speed, a car in a straight line at a steady speed, a car slowing down, and a car speeding up. So, a car will experience a resultant force when it experiences acceleration or deceleration. So you can automatically remove option C and D. Because remember that we studied that when there is a resultant force, it can cause a change in speed of an object, and option C and D represent that. That there is a resultant force, and the question asks us to find in which situation there's no resultant force, so you can automatically remove option C and D. As for option A, there is a resultant force due to the change in direction. For a change in direction to occur, a resultant force must act on an object, so you can cross option A. Only when you're left with the option B, go ahead and take that. Let's move on to the next question. Which properties of a body can be changed by applying a force to the body? Again, this is okay, so it's a bit different this time. Let's look at the first option, mass motion and shape. We know that the motion and shape of an object can be altered but not the mass. Cross that out. Mass and motion but not shape. Again, mass cannot be altered and shape has to be altered, so not that. Mass and shape, again, not mass. Cross that out. Motion and shape but not mass. That is spot on, so we get that. A force acting on an object causes some properties of the object to change, which list contains the only properties that can be changed by the action of the force. So again, this is similar to the question that we did above. I think the answer again is option D, because when a resultant force experienced by an object, three things happen: a change in speed, shape, and size. Also direction, that's not really mentioned here, but we're going to choose option D. Okay, another question. A box is being moved by a forklift truck. The total weight of the box is 3,000 newtons. The force exerted by the forklift truck on the box is 3,500 newtons upwards. What is the resultant force on the box? So the box has a weight which is of 3,000 newtons downwards, but the forklift exerts a force on the box which is 3,400 newtons upwards. Okay, so since they're in opposite direction, essentially we will subtract the forces from each other. So 3,500 newtons minus 3,000 newtons, which gives you a resultant force of 500 newtons upwards. So that would be option B. Let's move on to the next question. Which combination of forces produces a resultant force acting towards a right? So you need to have a resultant force that is produced. So you've got an object. There's multiple forces acting on an object, but when you add or subtract all of those forces, a resultant force should be produced on an object that causes the object to move rightward. So option A is a total force of 7 newtons acting to the right and a total force of 10 newtons acting to the left. So when you calculate the resultant force, it's 3 newtons to the left. You can eliminate option A. Option B, there is a force of 7 newtons acting towards the right and a force of 5 newtons acting towards the left. So actually we just found our answer. So because the resultant force that you get is 2 newtons to the right. So this is, I think, the only one that represents a force acting towards the right, because if you want to look further into it, option C represents an object that is not going to be moving, essentially in a state of equilibrium, and option D is going to represent an object having a resultant force of 1 newtons in the left direction. So you can just choose option B. Okay guys, I think that is the end of today's past paper session. So yeah, that's all I had for you guys today. Thank you all for joining me, and I'll see you guys in my next study session. Bye.